Now we'll see the term of this undamped vibration, damped vibration, forced vibration, all those stuff, what are the difference and how it can be differentiated and all those stuff. First, undamped free vibration. First, what is damping actually? Let me explain you using one example. In olden days, our fathers, if they had a cycle, or if our grandfather had a cycle, we had a seat of this kind particularly. My drawing is bad, I have said it to you earlier. We would have a spring, right? You remember? We have a cycle, and once we just push it, in childhood days we might have been playing with this, right? Once we switch on this, it will just go up and down like this. It has a spring, it doesn't have a damper. Okay, damper just reduces the oscillation to as much extent as it can. Now the modern days two-wheelers, bikes and all, we can't experience this kind of stuff because they have a damper. Okay, what we call damper is mostly, you can assume it to be a piston cylinder arrangement. Okay, that would give more sense to understand damper. For normal springs, this is the oscillation, that this seat will go up and down. That's what we experience, right? So this particular thing is undamped free vibration at many instances, but since we give our external force, we can call it undamped forced vibration. Okay, since we give some force to apply, okay, sometimes we give more weight, sometimes sudden impact load is there when we go into the pits. Okay, all these kinds of concepts are there. Now if you could see undamped free vibration, obviously we need a mass and a spring constant to run any kind of vibratory motion. If there is no spring, if there is no kind of thing which goes back and goes to and fro, we can't have a vibration system. So obviously for undamped free vibration, obviously we need mass and stiffness. Okay, we need two of them for sure to have a vibration system. Obviously, as I said to you earlier, since it's undamped, it's not at all damped, so we don't have a damping at all. Then it's free vibration. Okay, it rotates on its personal thing, nobody is coming and applying an external force, so we don't have a external force at all. So representation, as you have seen it earlier. Okay, so let's draw it in a vertical way. We have a spring constant and a mass m. So K and M is check, right? K is there, M is there, fine. Next is damped free vibration. We need to have a mass and stiffness for all the system, and along, since it's damped, I will have a damp. Since it's free vibration, we don't have an external force, it goes. So I'll have the same system. I have a spring, M is there, K is there, I'll extend this. So M is there, so piston cylinder arrangement, we have a damper, this is C. So since we have M, K and C, M, K, C, done. Next is undamped, it is not damped, forced vibration, you are applying some external force on it. Obviously we have mass, stiffness, no undamped, and external forced vibration is there. So say this is undamped forced vibration. So M should be there, and we have F of t. Now next we have all the things, damped, forced, vibration. So we have to have mass, stiffness, damping and external force. So we need to have a bigger fixed support, stiffness, damper, mass m, F of t, which is external force. So once you understand this, you would have a very good concept of this undamped free vibration, damped free vibration. You will be able to differentiate any kind of questions they ask for. So now particularly, since all this we are going to deal with, mostly as far as this tutorial is concerned, undamped free vibration, which is like mass and stiffness. Fine. So we shall go ahead with the first problem now.